Hello guys, welcome back. So in this video, we'll be solving Leetcode weekly contest 382, problem second 3020, find the maximum number of elements in subset. Okay, pause the video, read the question, then we'll proceed. Cool. So what does the question say? Question says that we will be given an array of positive integers nums. Now we need to select a subset of nums which satisfied the following condition. What is the condition? That if we select some number x, then it should follow this pattern. First it will be x, then x square, x to the power 4 till some power of x, let's say that is k, that is x to the power k, and finally in the reverse order whatever the numbers we have selected should be present. So like x to the power k by 2, then till like x to the power 4, x square, x. It's better to understand something like this. So what does the question say? That let's say if I chooses 3, so then it can follow pattern something like this: 3, then 3 square, then 3 to the power 4, then 3 to the power 8 till some power, let's say 3 to the power 16, and then again whatever the number we have selected, then 3 to the power 8 again, then 3 to the power 4, then 3 to the power 2, and then 3 to the power 1. So the total length here it will become how much? This 4 plus 1 5 and 4 9. So the question says that what can be the maximum length of such a subset? Okay, and there is another example for this 2. So it's nothing but 2 to the power 1, 2 to the power 2, 2 to the power 4, then 2 to the power 2 again, then 2 to the power 1. So that's what the pattern says. Now, initially it might feel like it's a very difficult question, but trust me guys, it's very easy. So what you need to realize is, so let's say if I know that there is number 4, okay, and the next number would be nothing but 4 square, the next number will be nothing but 4 square to the whole square, okay, and this was also nothing but the previous number square, and then here it will become 4 square to the whole square, or if we simplify this is nothing but 4, this is 4 square, this is 16 square, and this is what, 16 to the power 2, that is 256 whole square. Or again we can see that whatever the number we have here, it was nothing but the previous number, and if the 16 is what, this total number is 16, that is 4 square is 16, so we put 16 over here, and 256 is nothing but 16 square, that is whatever we have here, and this is equivalent to 256. So what we realize is that whatever number we start from, we need to check its power or its power 2, and then whatever number we have, again we will check it for its power 2, and then again so on. So we know that the pattern follow something like this, right? That if it is x, then x square, then x to the power 4, then something some power x to the power k, and then again till x to the power 4, x to the power 2, x to the power 1. So what can't we say that this x and this x, that is x to the power 1 or x, so minimum frequency of this x should be 2. Same goes for this x and this x, or that is x square and x square, sorry, here. So not here, not here, here. So x square and x square frequency should be minimum 2, and for x to the power 4 and x to the power 4 frequency should be minimum 2. And the moment we will encounter that if someone has frequency 1, so let's say we started moving something like this, that we have x, then we know that its frequency is, let's say, 3. So if its frequency is 3, then it's okay, we can take this, we can put one x over here and another x at the another end, right? Now from x we will move to x square. Let's say its frequency was 4, fine, we need just 2 and frequency was 4, so that means we can take x to the power 4, x to the power 4, sorry, x square and x square, not x to the power 4. Now the next number will be its square, and that is x to the power 4. So x to the power 4, let's say frequency was 2, it's okay, we can take it, x to the power 4, x to the power 4 both side, and we will have some remaining numbers like that 1x will be remained, 2 will be remaining here because 2 we are already selected, and 0x to the power 4 will be remaining over here. Now let's say the next number, that is x to the power 8, there was only one x to the power 8. So if that is the case, what will happen? So whatever the current count we have, current count as in how many numbers or how many elements we have already selected. So we have already selected 6, right? So if we'll have x to the power 8 frequency as 1, then our total number or the total number of elements in this subset can be 7. How? Because with this 6 element we can pick this x to the power 8 and we will form this pattern, right? That x, then x square, x to the power 4, x to the power 8, then again x to the power 4, then x to the power 2, and then x, right? But let's say if the frequency of x was 0, x to the power 8 was 0. So what we can do in that scenario? In that scenario, we can just leave 1x to the power 4, and then our pattern will become something like this: x, then x square, then x to the power 4, then again x to the power 2, and then again x. So in that scenario, see, we have two possibilities over here. If we have, I mean, basically three possibility will be there. So if we have more than 2, frequency greater than equal to 2, then we will continue this pattern. Else, if we have frequency equals to 1, what will happen? The number of current elements plus 1, plus 1. Why? Because that will be the our pivot element or the middle element. But if the frequency is 0 or that element is not present, what does that signify? That signify that we can just leave this element, we can fall back to the previous element, and instead of choosing two elements, we'll choose one of them, and our current count will decrease by 1 because we'll be leaving this one element, but our pattern or the our subset will be complete one. Okay, so from here you must realize that there will be three possibilities at each step if we choose x, right? That whether we can move forward, or we can just add one element, or we can fall back to the previous element. Okay, I hope till here this will be clear. Now realize one thing, that there's a pattern something like this, that 4 square, or initially it was 2, then 2 square. Okay, let me erase this a bit. So it will be 2 square, better to write 2 square, then 2 to the power 4, then 2 to the power 8, and so on. And this completes the series at, let's say, 2 to the power 16, and then again 2 to the power 8, 2 to the power 4, 2 to the power 2, and 2 to the power 1. So this was one pattern we found already. Okay, so does it make sense? Does it make sense to start again from here? Like, let's say 2 to the power 4, what if that is 16? So then 16, then 16 square, then what will happen? This will be 16 to the power 4, then again this will be nothing but 16 square, then 16. So we know that if we have pattern something like this, then the length of that pattern, or that subset will always be greater than this kind of pattern, right? Or for any pattern that we start from the in between of this, right? So what will we do? So whenever we find this kind of pattern, we'll simply subtract it, subtract the count or decrease the frequency. Why? Because we know that if we could have formed this, then this will always get counted into this one. Okay, so worst case that this is not getting formed, but if this is getting formed, then this will be counted inside this subset, right? This entire series will be counted inside this subset. So overall our length will either increase from this one, else it will remain the same. At this point will also be clear. So what we'll do, whenever we'll start from any x, we'll start decrementing its count in the same fashion, that we were doing it, right? I mean, if we are taking two elements, then we'll subtract -2 from the frequency. Like here also, like we are taking 2x square, then we'll subtract its frequency by -2. Okay, and yes, we do need to subtract for, if we are selecting just one element, then we should subtract just -1 or just 1. But you will realize that we don't need to worry about this one, but because this will anyways give the smaller length, but we should subtract it. Okay, now I hope till here everything would be clear. And one thing you will realize by now is we needed to have frequency, right? Like from our discussion we realized that we do need the frequency of all the elements. So what will be our approach now? First of all, we'll store all its frequency in a map, frequency of all the numbers. Now what will happen? Let's say if I am using ordered map. Why ordered map? Because I want this to come before this 16, right? So if I'll using ordered map, the keys will be sorted. So let's say if we have 2 over here, then 16 over here, then 20 over here, let's say 1 over here, so and all its frequency, then what we can do, we can choose this as x, right? Initial x. then we can choose its x square, then again x to the power 4, then again, and so on and so forth. So what will happen, we'll keep on going this series and decreasing the count, and finally if we'll reach our pivot element, that is if somewhere we found some x to the power k frequency as 1, or will or if it is less than 0, then we'll just come out of the while loop. It's better to explain from the code. Let's see here. So what we are doing, we are just making a map, ordered map. Why ordered map? We already discussed, because we want to pick the smaller number first and then the bigger number. Okay, now, so first of all, we stored the frequency of all the numbers. Now we started for the first element. We considered this as x, and current is equals to 0. What does this current signify? This current signifies what is the maximum possible length of the subset which starts from this x. Okay. Now, if frequency is of x is greater than equal to 2, then what we can do? We can put this x on the both side, right? That's what we discussed. Then we will move to x square, and x square will be nothing but x into x. So initially x was x, then after this step x will become x square. Now we'll check if the frequency of x square is greater than equal to 2. If this condition satisfied, then what we'll do? We'll put both this x square and both these ends. And now if we'll, and at the same time we'll decrease the count. We'll decrease the count. See, we are decreasing the count of this x, whatever x we are selecting. Okay. And now if we have selected this x square, our new x will be this x square to the whole square, or this x square into x square, that is x to the power 4. And that's what happening here as well, because this x has already become x square, right? So now if at any point this condition fails, what does that mean? We are either going to find a pivot element, or we'll have to fall back to the previous element. So we are checking if the frequency of x, what does that mean? If it's not greater than 2, that means it can be 1. So if that is 1, then we can have, let's say, if this after x square x4 was 1, so we can have this pivot element and we can add this element to our current element. Add this element means add 1 to our current. Why? Because that will give the total number of elements in this particular subset. Else, if this was not there, what we'll do? We'll make this as pivot and we'll discard this x square. So we'll decrease our current by 1, because initially it will 4. We are discarding one element, so it should be 3. So that's what we are doing over here. Okay. And now finally we realize that by choosing this x, this can be the, or the whatever the cur has the current value will be the maximum size of element that we can form. So maximum size of the subset that we can form. So we'll maximize answer. And finally, we are returning the answer. Ideally, if you want, we should subtract the frequency by 1 over here, but that won't affect much. That's why I didn't bothered about that. But I hope this would be clear to you. And yeah, if someone wants to talk about the time complexity, we should realize that in overall we are kind of iterating over just n elements, or all the elements inside this nums, because we are decrementing the count by -2. So let's say in the worst case, if we'll iterate this entire map, we'll iterate over just n elements. Okay, so overall it will become big O of n, but we are using map which is kind of sorting it. So in the worst scenario, it can go to big O of n log n. Okay, space complexity will be also big O of n, because we are using this map to store it. I hope that would be clear. But if you guys have any doubt, let's try to submit this. Yeah. So if you guys have any doubt, do let me in the comment section. Okay. See you in the next video. Bye.